So you are welcome again in our organic class. I will start with the reaction of phenol. The reaction of phenol, I give you the main idea about the reaction of phenol. You have more details information. If you go back to the reference, I put it on the model. I give you 2 books as reference, actually very good books. So if you want more understanding, more information, more details, you have to go to the books, okay? So here in our lecture, I will just explain for you the main idea, the main principles about every subject. So we start with the reaction of phenol as acid. Look, he said as acid, okay? Phenol as acid. So why the phenol can be react as acid or work as acid? Why? What do you think? Why? Because have what? Have proton. Have a proton. Proton, hydrogen bonded to the oxygen. Have a hydrogen bond bonded to the oxygen. Hydrogen bond bonded to the oxygen. Okay. This hydrogen bond is what? Partially positive or negative? Partially positive. That meaning is a proton. Proton. What means proton? That means hydrogen atom is electron deficient. Tamam? Hydrogen atom electron deficient. So can be work as acid, can be donate this proton to what? To base. Okay? To base. This is the idea. So because phenol are more acidic than water. Why? This is a question for you. The phenol is more acidic than water. Why? Explain for me. The first question. Because the stability of the conjugated base. First step, you have to write the conjugated base and look to the conjugated base, stability of the conjugated base. If your conjugated base is stable, that meaning it will be stronger acid. So anyone is more stable, OH minus or O minus for the phenoxide. We say this phenoxide anion. O minus. Why this more stable from OH minus? Why? Because the resonance. The resonance with the benzene ring. This is the answer. Write the resonance, a complete answer. Okay? This is the first question for you. So, the following reaction goes essentially to completion the produce water-soluble sodium phenoxide. Okay. If I have phenol compound and I have NaOH as strong acid, this strong acid, okay, strong acid, directly give you phenoxide anion and H2O. So, the reaction is equilibrium. Look, equilibrium. Two arrow, use it for this equilibrium. Okay. Now equilibrium. Anyone is a preferred one. The left side or the right side? Why? Why? Because more stable anion here. Okay. Here on this side you have minus on the oxygen. Here also you have minus on the oxygen. Have Na plus OH minus. Milha, salt. Anyone is more stable. The minus on the oxygen for phenoxide anion. This is the more stable one. For this reason, look, أو سهم, this arrow is longer than this. Okay? For this reason, the reaction will be go to the product. The reaction will be happened. The reaction will be happened. So, the corresponding reaction of one hexanol, no كحول, not phenol, كحول. Hexanol with aqueous sodium hydroxide doesn't, أو مهمة, doesn't occur. يعني there is no reaction. Why? Because alcohol, yes, is weaker acid than phenol. Cannot be react with this basis. Okay. Cannot be react with NaOH. Why? Because is weaker acid. So, if you look to here, where is the minus here? Where is the minus on this side? Where is the minus? Here? Minus? Here? Here? Yes, OH minus. OH minus. Look to the minus here. Where is it? Oxygen. This alkoxide. Anyone is more stable. RO minus, like that. You have to decide, okay? Anyone is more stable. RO minus or HO minus? Anyone is more stable? HO. Okay, look. This R is donating. It will be increase the electron density. It will be less stability. This is more stable one. Okay? This is more stable one. That meaning That meaning if I say to you, this is more stable one, okay, this equilibrium, it will be preferred to this side or to this side? To this side. That meaning the reaction cannot be happened. If the reaction happened, it will be give you another starting material, again starting material. If the reaction happened, I give you again the starting materials, okay? That meaning there is no reaction can be happened because the equilibrium, it will be preferred for the, we say it for the reactant side, have a reactant side, have a product side, okay? For the reactant side. So, the fact that phenol dissolved in aqueous, he said here, phenol is dissolved in aqueous sodium hydroxide, whereas most alcohol with 6 carbon atom or more don't soluble in aqueous NaOH because there is no reaction. Okay, because there is no reaction. Give us convenient means to distinguish between phenol and most alcohol. So if you have beaker, this beaker has phenols and alcohols. I told you I want to separate this compound from each other. How? Give me idea to separate this compound. Okay. طبعا هذا بيجن phenol alcohol with مثلا an ether, مثلا an ether as organic solvent. What you have to do? Directly, you said I can distinguish between phenol and alcohol by the reaction with NaOH. So I will put NaOH, for example, 5 normal. يعني 5 normal. What meaning NaOH 5 normal? يعني NaOH dissolved in H2O. Okay, the concentration, the H2O. Now I put NaOH H2O here. What will be happen? Give you 2 layer. Give you our beaker. This is your beaker. This your beaker. Give you H2O. Give you the ether. This is the ether, and give you the H2O. So anyone it will be react with NaOH, the phenol, and give you phenoxide anion. That meaning directly go to the H2O. This is the phenoxide anion. This it will be go to the H2O. Okay. Alcohol remain with the ether. Alcohol remain here. Alcohol remain here. This alcohols remain here. That meaning you have 2 layers. One of them with the phenol, one of them with alcohol. How I can separate this 2 layers from each other? By using what? By using separating phenol. هي separating phenol. تمام, separating phenol. Okay, separating phenol, and you will be take the phenol after acidification of the aqueous layer by using acidification. So, also he said phenols, strong acid or weak acid? If you compare the phenol with the H2O, yes, the phenol is stronger than H2O. Okay, but if you compare the phenol with carboxylic acid, anyone is stronger? Carboxylic acid. So, if you have carboxylic acid, for example, the phenol. Okay. And carboxylic acid ROH, and you put both of them, this and this, you put it NaHCO3, sodium bicarbonate. Sodium bicarbonate, weak base or strong base? Weak base, not like NaOH. NaOH, strong base. This is weak base. So the weak base, it will be react with strong acid? Yes, strong acid. Strong acid can be react with the weak base. Strong acid can be react with the weak base. Now I come to here. Weak acid can be react with weak base? No, cannot be react with the weak base. Tamam? So if you have beaker like this idea, beaker, conical flask, and has both of them, phenol and carboxylic acid. How you can distinguish between of them? By the reaction with weak base, like what? Like NaHCO3. Okay, like NaHCO3. Auji, it is good question for you. How you can distinguish between phenols and the carboxylic acid compound أو سيارة مهمة. Okay, درستها؟ PCR. How you can distinguish? Distinguish and separation phenol from alcohol and carboxylic acid. Okay, this. So I can give you many names, many questions about separating idea, and you have to write for me the answer. Okay, so like this equation. Okay, look, your laboratory instructor, يعني المامسطة, the teacher work in the laboratory, told you, give you a mixture of 4-methyl phenol. هذا phenol رقم هيك. يا دوي benzoic acid. 3 toluene. هذا هرسة. All of them in the beaker, in the conical flask. Okay. Assume that you have available common laboratory acid, base, and solvent. Okay. You have all acid, you have all base, you have all solvent. Okay, solvent. Explain. You have to put plan. خطة. Okay. How you will be separate this mixture from each other. Okay. How you can separate. You have to think. And this homework for you. Okay. This another type of homework. He said, assume that each of the following mixture was added to the flask. Look, the same idea, to the flask of separating phenol. Okay. That contain diethyl ether as solvent. Have a diethyl solvent. Okay. Put note. Diethyl ether solvent as organic solvent. Okay. And mixed will. What will be happened? In which layer diethyl ether? In which layer? يعني in diethyl ether or in water? The following mixture it will be happened. يعني if you have this, apply this, what will be happened? It will be go to the aqueous layer or it will be go to the anaqueous layer, to the organic layer, to the ether layer. If you have this and this, what will be happened? If you have this and this, what will be happened? Okay, and here give you the answer. طبعا هو محلول. This is the answer here. Okay, but you have to know to understand the idea. So, acylation of phenol. This about acid and base for the phenol and the reaction with the bases is finished. Now we start with the acylation of the phenol. The idea, you know the acylation reaction, yes? Last year, you take the acylation reaction. Acylation, alkylation, bromination, nitration, halogenation, yes? So, here, just let us remember our reaction in acylation. We use مثلا benzene ring. This is the benzene ring, yes? And I want to make acylation for this compound. What I have to use in acylation, I use acid chloride, R, this Cl, مثلا X, by using what? Catalyst, Al, Cl3. تمام? Catalyst. So, I use catalyst. Without catalyst, there's reaction? No, there is no reaction. But with catalyst, the reaction will be happen. And any type of reaction will be happen. The product will be this. It will be this. Give you ketone. Have a ketone. Any type of reaction, this. Any elimination? No, it is not elimination. Addition? No. I remove a proton, hydrogen, substitution. Then, substitution with what? This electrophile or nucleophile? This electrophile, that meaning electrophilic, aromatic, substitution. This is the type of reaction. Okay, electrophilic, aromatic, substitution. So, this is acylation for the benzene ring. The same thing here. If I use phenol, I will change. If I use phenol, OH, the first thing you don't need catalyst. Without the catalyst, the reaction, it will be what? Happened and give you this ortho and para isomer. This is the isomer. Why ortho para isomer? Why? Why two component? To protect. Why to protect? No, not stability. Because the OH is orthopara director. Because the OH is orthopara director, not meta director. Okay? If I told you why the OH is orthopara director, you go to the stability and resonance structure. Tamam? So, first thing, you don't need catalyst. Okay, you have to stop here. Why we don't need catalyst? Why? Why no? No, why? Because then anyone is more reactive than other. Benzene or phenol? Benzene or phenol? Phenol more reactive than benzene. Why? Because the OH group is what? Donating a group, increase the electron density over carbon of the cycle of the benzene ring. That meaning make the benzene ring is more reactive toward what? Toward electrophile. Tamam? Okay? So, because the OH group is the donating, increase the reactivity of the benzene ring, for this reason, phenols is more reactive than benzene in many reactions, not just the acylation. Okay? Also in the bromination and alkylation and over all the remaining reaction. Okay? This is the first idea you have to know. So, here, he said, if you read here, acylation agents such as acylic chloride, this is the acylic chloride, or carboxylic acid anhydride, okay, can react with the phenol either at aromatic ring, and the reaction it will be happened on the benzene ring. We said carbon acylation like this. Carbon acylation. Acylation happened on the carbon. Or in the hydroxyl oxygen, or the acylation will be happened on this oxygen. We said oxygen acylation. Okay, depend on what? Depend on the catalyst that be used in your reaction. So, for example, here, the condition of Friedrich-Krafft reaction treatment with acylic chloride and acid anhydride in the presence of what? Aluminium chloride is as catalyst. If you use aluminium chloride as catalyst, the reaction will be happened over benzene ring. If you use without catalyst like that, the reaction will be happened on the oxygen of the acylic chloride of the acid anhydride. So you have two types of the acylation for the phenol. This number one, and the second type of the acylation, it will be, we say the alkylation on the oxygen of the hydroxide. This shape of electron attack here, and it will be give you what? Give you this. Oxygen, carbonyl, R. Okay. Now, any compound this, have a ketone. This ketone, have a ketone. Or this ether, have a ether? Not ether. This carboxylic acid? No. Kuhul? No, not kuhul. Water? Ester. It is ester compound. So, if the acylation happened over benzene ring, give you ketone. If the acylation happened on the oxygen of the hydroxylic group, give you ester. Tamam? The catalyst, it will be, okay, it will be acid or base. I will be used here. This here, use aluminium chloride, yes? For example, Cl3. If you want the alkylation, it will be happened on the benzene ring. If you want on the oxygen, it will be used acid or base. Acid or base. Next slide. Any acid. Strongest. This H2SO4. So, the catalyst that be used for the acylation on the oxygen of the phenol, it will be acid or base. How it will be work? The acid or base. This acid and this base. Look, this is parafluorophenol, this compound. It will be react with acetic anhydride by using acid. Where's the alkylation? It will be happened on the benzene ring or on the oxygen? It will be happened on the oxygen. هذا قاعدة خلاص on the oxygen. And give you ester, other ester. give you ester. تمام. Also, if you use the phenol with acetic anhydride or acidic chloride with the base, directly the alkylation, it will be happened on the hydroxyl group. Okay? This is the alkylation. So, if you want to understand the idea how it will be work this or it will be work this, I'll explain for you here. Okay. So, look, this is phenol, nucleophile. My question is strong or weak nucleophile? Huh? Strong or weak nucleophile? This. Then. Nucleophile, nucleophile. Anyone is stronger than other, this or this? Ya sari and Abini. Ya sari, this the upper one. Why? Chinko? Why? Why? More stable? No, بالعكس. Less stable. Less stable. هكا less stable, it will be active, more active. Yes, less stability, more active. That meaning it will be stronger nucleophile. Okay, why is stronger nucleophile? Less stable. Other directly is negatively charged. Nucleophile طلبة, it is negatively charged, stronger nucleophile. This is neutral. Have a positive negative here. That meaning this is neutral. Okay, it's weaker nucleophile. For this reason, phenols is weak nucleophiles. Have a nucleophile, there is the nucleophile. But it is neutral nucleophile, not strong nucleophile. So, I come to here. This electrophile, yes? Electrophile, this electrophile. Strong or weak electrophile? Partially positive, partially negative, partially negative. This is strong or weak electrophile? Full positive? No. Partially, يعني weak. Weak electrophile. Weak nucleophile, it will be react with weak electrophile. In your opinion, reaction, it will be fast or slow reaction? Slow, weak with weak. Slow reaction. So, I want to catalyze the reaction. I want to catalyze the reaction by using what? An acid or base. Yalla, with acid. The acid, it will be work like that. Acid, proton. Okay. The proton, it will become to this oxygen or to this oxygen? Huh? If you want to this oxygen, it will be like that. It will be like that, yes? And this, it will be positively charged. If add من electrophile, add من electrophile. There is no reaction. That meaning your choice is wrong. What? For this reason, the oxygen will become to here. Okay? The oxygen, it will be add. It will be protonated. The oxygen of the carbonyl compound. Okay? That meaning it will become to here. And this, it will be positively charged. We have resonance structure here or we don't have resonance structure? Here? We have this pi bond, it will be open to the oxygen and positive, it will be on the carbon. On the carbon. Okay. Now, weak nucleophile can be react with the strong electrophile. Yes, strong electrophile, and the reaction will be fast. Okay. Okay, nothing. I think nothing here. Okay. The weather is hot. So the reaction is, it will be increased, it will be activated by using acid. We go to the base. How the base, it will be work. Do you understand? Do you understand? Do you understand? No question? Okay. I will go to use base. Okay, now use base. Yellow. Remove? Okay, remove. Not all. If I want to remove, to use base, like NaOH, NaOH, OH. Now, how the NaOH will work? This is the question. How the OH will be work? The OH directly go to, where's the proton? Our proton very high? Proton very high? Other base. Where's the proton? Here the proton? No. Here? Other proton. Tamam? This is the proton. That meaning directly the hydroxide remove the proton. And give you what? Give you phenoxide anion. This is the phenoxide anion. This O minus. Phenoxide anion. Strong nucleophile or weak nucleophile? Strong. Directly attack fast. Attack. And give you the reaction. طبعا, where is the attack? This is the leaving group. It will be go out and give you the product. Give you the product. You understand? Okay. Now, this is a question for you, طبعا. You can resolve as homework. Phenol in the second subject here, the third, reaction for the phenol is Williamson synthesis. طبعا not a new reaction for you. I think you used it before that. You take it before that in the last year. So, as easy reaction, actually, by two-step reaction. Williamson. طلبة. The phenol is in Williamson synthesis. Phenol can be converted to the ether, okay, through what? Through Williamson synthesis. So, because phenol are more acidic than alcohol, we know this is more acidic than alcohol, they can be converted to the sodium phenoxide, okay, by reaction with the base. Sodium phenoxides through the use of sodium hydroxide. Rather than the sodium hydride or metallic sodium, the reagent be used convert alcohol to the alkoxide base. What he said here, he said if you have this phenol OH, phenol directly, it will be react with NaOH, yes? Give you phenoxide anion. And this phenoxide anion, it will be enter to the second step reaction in Williamson synthesis. This, the alkyl halide. I will stop enter here. So, but if you have Kahol, not phenol, Kahol, ROH. ROH can be react with NaOH? No, cannot be react with NaOH. Why? Because it's weak acids. Weak acid. So, in here, you can use strong, very strong base. Like what? You take it last year. Okay. Like what? As what? Stronger than this. I want base stronger than this. لا, lithium aluminum hydrate? لا, reducing agent. No. يلا NaH. Sodium hydride. Okay, the hydride here, I told you it is very strong base, H minus. Can be removed this proton and the reaction will be happened. Okay, can be used. So, this here, the meaning. Sodium hydride. Sodium hydride. So, in Williamson synthesis, we used a phenoxide anion, and the phenoxide anion will be entered to the second step reaction, the reaction with alkyl halide, to give you ether. So, if I have this here, for example, CH3, CH2, Br. This is nucleophile. Where's the electrophile here? This. Partially what? Negative. Partially positive. That meaning this attack this carbon and this it will be leaving group. By any mechanism, SN2. Why SN2 not SN1? Because the alkyl halide here is what? Primary alkyl halide. For this reason, our mechanism it will be SN2. SN2. Okay? Easy reaction? Just this. This is the Williamson synthesis. Okay? Maybe you have another example. This is the mechanism here. The mechanism. NaOH give you phenoxide anion. Phenoxide anion attack alkyl halide, or not just alkyl halide, also this type of compound. If you have alkyl halide, this is the leaving group. Mana this leaving group? Okay, there is another type of sulfonide. This CH3. O, S, O, 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 CH3. This is the compound here. Okay. Also, this has leaving group. All this is what? Leaving group. That meaning if you have a nucleophile like that, phenoxide anion nucleophile can be attacked, and this it will be leave the structure and give you alkylation of the oxygen and give you ether compound. Ether compound. Okay. Now this ether, Williamson synthesis. Okay. As the synthesis of normally performed here in this reaction, a solution of phenol and alkyl halide is simply heated in the presence of suitable base such as potassium carbonate, and the reaction to be directly give you ether because you have phenol and you have alkyl halide. The directly by using base, it will be give you ether compound. Okay, ether compound. Don't forget this node. Williamson synthesis طلبة to synthesize the ether compound. Ether compound. Okay. Fourth is the reaction on the benzene ring of phenol. Actually, you know this reaction. Okay, it is not new for you. You know all this type of reaction for the we said alkylation or to the substitution on the benzene ring, or over aromatic cycle. Okay, for this reason I will give you مثلا bromination, alkylation, acylation, nitration, sulfonation. Okay, all this type of reaction you take it last year and just we repeat it for you again here. So in most the reaction of phenol behave as nucleophile and the reagent that act on them are electrophile. This is nucleophile and it will be react with the electrophile. This is the meaning here. I don't know. It is called or nothing. Okay. So I can open the door like that. Oh, no. Okay. Useful. Okay. So the first one, he said either the hydroxyl oxygen or the aromatic ring may be the site of the nucleophilicity here, the nucleophilic reactivity of the phenol. Reaction that take place over on the ring lead to the electrophilic aromatic substitution. That meaning we have here nucleophile and we have here electrophile, and it will be open. Okay. So it will be here. It will be electrophilic aromatic substitution. Any type of reaction, this bromination. Okay. We use AlBr3 here. We don't use it. Why? Because the phenol is more reactive than benzene. In benzene, yes, you need catalyst. Here, you don't need catalyst. Okay, I told you before that you don't need catalyst. So, if you use excess amount of the bromine, you will be get this compound, the substitute on the ortho and the para. Meta, there is no substituted. Why? Because the OH is ortho-para director, not meta. Okay? Because the oxygen is the hydroxyl group is ortho-para director. So, monobromination of the phenol. If you want monobromination of the phenol, they use to decrease the activity of the bromine by using CS2, the carbon disulfate. Where is it? This carbon disulfate. This is the carbon disulfate. Okay, it will be decrease the reactivity of the bromine, and it will be give you just parabromination. The main product it will be parabromination on the benzene ring over aromatic cycle of the phenol. To be give you look to the para. How much? 80. Okay, the major product it will be this, the major product, but in using different condition, CS2 and cold condition in ice bath. But if you put it at room temperature without CS2, it will be give you ortho and para. Okay, both of them it will give you ortho and para. But we decrease the reactivity of the bromine. For this reason, the main product here it will be para substitution. Nitration. You know the nitration, yes? Nitration for the benzene ring, HNO3 and H2SO4. But here just we use HNO3, enough. Why? Because the reactivity of the phenol. Just use HNO3, give you the nitration, and ortho, para director position here. Ortho substituted and para substituted. Okay? Ortho here, yes, it will be happened, but in less amount. The major product, it will be para. Okay? Here, look, we used room temperature. We used room temperature. Both of them, it will be happening here, right? For the ortho position and para position. Okay? This is the nitration. Do you remember the mechanism? For the electrophilic aromatic substitution, the same mechanism, two-step mechanism. Step number one, carbocation formation, step resonance. Step number two, elimination, and your aromatic system, it will be formed again. Okay? Malnitration, malbromination, malalkylation, acylation, all of them the same mechanism. All of them the same mechanism. Okay. Sulfonation, phenol react with concentrated sulfuric acid to yield mainly the orthosulfonate product if your reaction happened at room temperature. If you use heating over to 100 degree, the reaction it will be happened on the para position. Okay. Now, how this it will be happened on the ortho, how this it will be happened in the para, it is not our subject today. Because this we go to the thermodynamic and kinetic control. It is related with physical chemistry, okay? But it is not our subject. But the idea is the thermodynamic control, thermodynamically controlled. This is kinetic controlled, okay? Give you the ortho, this is give you the para, okay? But the idea, this is the idea, the main idea, this is the main idea. If you want to convert the ortho, if you have ortho derivative, convert to the para derivative, yes, easy. Put concentrated H2SO4, also heating, it will be converted to the para derivative, para isomer. Okay? How it will be converted to the para isomer? It is not related with you now. يعني mechanism, just I will give you the idea. Yes, this here the measure. Or this here at room temperature, this is the measure. Or this at high temperature, this is the measure. Okay? Okay. Look, the second type of reaction for the phenols is the Kolbe reaction. Kolbe reaction, actually, look, he said here, the phenoxide anion is even more substitutable to the electrophilic aromatic substitution than phenol itself. Okay? He said here, phenoxide anion is more reactive than phenol itself. Why? Just 1 minute. If you have phenol, this is the phenol, and you have phenoxide anion. This the phenoxide anion. Anyone is more reactive than other, this or this? Actually this, because this is negatively charged, and yes, it enters fastly to the resonance with the and all the carbon here and ortho and para will be has negatively charged, and it will be react further than phenol itself. Okay, because the negatively charged. This is the meaning here. Why this for you? Why have a job? Okay, so use is made a high reactivity of the phenoxide ring in a reaction called Kolbe reaction. In Kolbe reaction, carbon dioxide act as electrophile. Look what he said here. Kolbe reaction is usually carried out by following sodium phenoxide to absorb carbon dioxide and then heating the product up to 125. Under what? Under pressure, several times. Do you think this is method can be used in the lab? In your lab, the normal lab? Under pressure or many types of sodium dioxide. Actually, this procedure is industrial procedure, but this is the idea from here, okay? Cannot be normally work in the lab. So this is industrial methods. It can be used, this method, useful. So, in the Kolbe rearrangement, what happened? Phenoxide anion, it will be react with carbon dioxide. Carbon dioxide is your electrophile now. This carbon dioxide is your electrophile now. Give you this compound. This make double bond and this open to the carbon, attack this carbon for carbon dioxide, and this it will be open. Give you this intermediate. This intermediate is unstable intermediate. By heating, it will be entered to the tautomerization give you the sodium salicylate. Okay, sodium salicylate. I just remember for you how that tautomerization will be happened. Last year, if you remember, we take the enol ketoform. Do you remember the enol ketoform? Enol. Then, if you have this, what this compound now? Alkene, alkyne, alkane, alkene. Okay, this enol. This is enol. Enol, actually, it is less stable. It will be converted to the keto form directly. And this here, it will be converted to make double bond, and this proton, it will be converted to this carbon, and give you this. What this compound? Ether? Acid? Ketone. This is enol ketone tautomerization. Isomers, okay? Enol ketone tautomerization. The same thing here. This is ketone. It will be converted to the enol form. This is the enol form. This is the keto form. Okay. Now, here in alkene, anyone is more stable? Enol form and ketone form? Huh? Ketone form, yes, is more stable. But here, anyone is more stable? Reverse is the enol form. Why this the enol form is more stable? Because the resonance of the benzene ring. Look, we have resonance here on the benzene ring, makes stability for this compound. But here, there is no resonance. Okay? Anyone is best more stable, resonance or without resonance? Of course, resonance. For this reason, the stability, the tautomerism, it will be go to the enol form, and give you the sodium salicylate. Okay, now, sodium salicylate and salicylate in salt figure. This is the salt figure. How I can get the neutral figure for this compound? I want neutral compound for this. It's salt now. How I can get neutral compound? By reaction with acid. Put acid, it will be directly give you what? Give you a neutral compound. Okay? So if you have like this, CH3 O Na, salt plus proton from HCl مثلا أو H2SO4 give you what? مثلا HCl give you what? Directly give you a neutral form CH3 carbon OH plus NaCl. The same thing here. بالضبط exactly the same thing here. This is salt form, give you a neutral form. Okay? Give you a neutral form. Now, this is salicylic acid. If I want here, OH. So, this is salicylic acid, phenol compound with carboxylic acid. If I want to make alkylation here, okay, I want to make alkylation with مثلا CH3 Cl, for example, Cl. Give you what? Alkylation at مثلا acid, I will use acid. Look, I used acid, not aluminum chloride. If I use aluminum chloride, the alkylation will be happened here on the aromatic ring. But I use acid, that meaning the reaction to be happen on the oxygen. Directly it happened on the oxygen. OH and oxygen. This, the alkylation to happen on the oxygen. And this compound is what? Is aspirin. Do you know the aspirin drug? Yes. Most of the people use aspirin drug. Okay? Most of the people. So, this is the aspirin. Now, if I told you how you can prepare the aspirin compound, give me plane to prepare the aspirin compound by using Kolbe reaction and then alkylation. Okay, Kolbe reaction and then alkylation. So another type of reaction, you know it, you take it before that, halogenation. Halogenation. Okay, nitration. You know the nitration, you know the halogenation. Nitrosation, now this is new for you, nitrosation. The same, it is near from the nitration, but the electrophile is different here. Is the NO. It will become from the nitrosium salt. It will become from sodium nitrate. Okay, it will come from the sodium nitrate. He said, on acidification of aqueous solution of sodium nitrate, the nitrosonium ion, this the ion, is formed. This ion is your electrophile, is the electrophile in the reaction. Okay? So which is weak electrophile and attack the strongly activated benzene ring of the phenol. The phenol directly attack with this electrophile. Okay, and the product of the nitrosophenol, it will be formed. This nitrosophenol. This is new for you. By mechanism, without mechanism. Okay. So, sulfonation, also heating phenol with concentrated sulfuric acid, it will be give you directly the SO3H, the sulfonation. Mechanism, the same mechanism. Carbocation formation, resonance, and then elimination. And our aromatic system, it will be come back again. Okay. Friedel-Crafts alkylation. Yes, we know Friedel-Crafts alkylation. Look, the phenol compound, I use it alkyl, but without catalyst. I don't use AlCl3 or ALS high, but I will give you the idea here. In alkylation, normal alkylation reaction condition, you know the aromatic compound, it will be treated with what? With what? In alkylation, any type of compound used for alkylation. Any compound, RX, alkyl halide. Yes, alkyl halide used for alkylation. Without OH, yani just benzene ring, we use catalyst, AlCl3, Al. Okay, but we have phenol, we don't use catalyst. If you want your reaction to be faster, yes, you can use catalyst, the reaction will be faster. Okay, so here, not just the alkyl halide can be used for alkylation also. Also, tertiary alcohol, he said here, tertiary alcohol can be used here. This tertiary alcohol, R, this tertiary alcohol. Okay, why tertiary alcohol can be used here? Why tertiary alcohol can be used here? What do you think? He said here, alcohol with acid serve as source of the carbocation. That meaning alcohol here can be give you carbocation. Okay, attack the carbocation on the electron rich ring of the phenol about the alkylation. So here, tertiary butyl alcohol. He said source for the carbocation. This source for the carbocation. If I remove the OH from here, give you what? Give you carbocation, this carbocation. Now, this carbocation, primary, secondary, or tertiary? Tertiary. Stable or not? Stable. Stable than secondary, stable than a primary carbocation, okay? For this reason, this is stable electrophile, and directly the benzene ring can be attacked, this electrophile, and the reaction will be happened. Directly the reaction, it will be happened, and give you the product OH R alkylation. المهم هذا what all this is alkyl group alkylation. Okay, يعني we can use alkyl halide RX, we can use also alcohol because alcohol can be source for the electrophilic carbocation. Friedrich-Kraft acylation in the presence of, look, aluminum hydrate, the alkylation will be happened over OH or over benzene ring with aluminum, with catalyst, over benzene ring. Okay, without AlCl3 مثلا بس acid بس base, the alkylation will be happened on the OH أو مهمة طلبة, it will be happened on the hydroxyl group. Okay, this is important note. You can write notes. Okay, this homework for you, predict the product for each of the following reaction. This for you. Resolve the homework, and if you have a question, I will. So now the next type for the reaction of phenol is the quinone. Actually, quinone is important compound also, but we have a fewer type of reaction to produce the quinone from the phenols. I will give you here the idea. Phenols are more easily oxidized than alcohol, and large number of inorganic oxidizing agents can be used for this oxidation. So if I used, for example, this phenol, actually we have two types of the diphenolic compound, okay? Phenol that has dihydroxy group. One of them, this 1,4-dihydroxybenzene, 1,4-dihydroxybenzene, by oxidation, okay, it will be give you this, the quinone, 1,4-quinone, okay? And the other type of the 1,2, I will give you the next slide, but this is the idea here. The phenol oxidation that are of the most used in the organic chemistry are those involving derivative of 1,2-benzene diol, other 1,2-benzene, okay? Benzene diol, 1,2. This is 1,4, and we have 1,2 here, 1,2-benzene diol. Next slide. They call it pyrocatechol. They call it pyrocatechol. And 1,4, this like this, 1,4-benzene diol, it will be hydroquinone, other hydroquinone. Okay? Oxidation of the compound of this type with silver oxide or with the chromic acid yield conjugated dicarbonyl compound, call it quinone. This is the conjugated. What means conjugated? You have to know that meaning conjugated. Conjugated, that meaning we have double, single, double, single, double. This is the conjugated system. Okay? Double, single, double, single, double. This is the conjugated system. Also, 1,2, it will give you the same conjugated system. Okay? So, next slide, if I show you the example here, what we have here, we have the hydroquinone. This is the hydroquinone, 1,4-dihydroxybenzene. This is the 1,4, and it will be oxidized to the 1,4, this 1,4 benzoquinone, para-benzoquinone. Okay? Mechanism, there is no mechanism, without mechanism. Just I want to know the reaction. Okay? So if you have 1,2-dihydroxybenzene, it will be give you 1,2-benzene quinone. Okay? It will give 1,2-benzene quinone. This is the idea. طبعا this reaction, this is oxidation, yes? Reverse is what? Reduction. That meaning if I use this and reduction agent, وكيتشيا reduction agent, like what? Reduction agent. Like مثلا lithium aluminum hydrate. Okay? Also it will be give you, it will be give you hydroquinone again. This reverse, it will be give you this compound again. Okay? Yeah, this reaction is reversible depend on the agent that you use. Okay? That you use. Next slide, what I have to do here to explain for you this is the reverse. Okay? This is the reverse reaction. Okay. The The another type of the preparation of the phenol is from the Claisen rearrangement of aryl ether. Okay. Now, any question? No question? So if you have like this long chain, for example, and you have this group. What is this group? Do you know? Any group this? Ethyl, alkyl. Tamam. This? Propyl. This? Bromo. Tamam. This is bromo. This? This? Vinyl. This is vinyl. Okay. This is allyl. Okay. This is allyl group. Now, our type of reaction, Claisen rearrangement of aryl ether. That meaning you have ether. This ether, aryl. This is the aryl. Okay, AR. This is substituent, maybe substituent. Allyl, this is the allyl. Okay, this type of compounds. AR, oxygen, allyl group. So, heating allyl phenyl ether over to 200, okay, high heat, 200, he said here effect an intramolecular reaction called a Claisen rearrangement, it will be happened. Look, he said intra, not intermolecular. If I say to you intermolecular, that meaning between two molecular, this compound with this compound. But here, intramolecular compound reaction, that means at the same compound, the reaction will be happen with itself. Okay, with itself, the reaction will be happen. On the same molecular, the reaction will be happen. The rearrangement it will be happen. So this is the meaning for intramolecular rearrangement, intramolecular reaction. It is like hydrogen bond. We have two types of hydrogen. We have intermolecular hydrogen bond. We have intramolecular hydrogen bond. The same thing. So the product of the rearrangement is ortho-allyl phenol. The product it will be ortho-allyl phenol. Look, from the ether, give you phenol. Okay, from the ether, give you phenol. So how this rearrangement will be happen? Actually, it is not so complex, but also we have tautomerism here. It is like Kolbe reaction. Also, we have keto-enol tautomerization. The same thing here. I will show you next slide. 1 minute. So, this here. Oh, 1, 2, 3. This is aryl ether. Okay. He said here the step by step I explain for you. Also, I will refer for you here. He said the reaction takes place through concealed rearrangement special khas. Okay, in which of the bond between C3 of the allyl group and ortho position of the benzene it will be formed. This carbon number 1, 2, 3. Oh, carbon. Where's the ortho position? This the ortho. And also we have two ortho position. Okay, the near from the carbon 3, this is the ortho position. Okay. Now we have a new bond here. It will be forms. Okay, the new bond. And what he said, at the same time that the carbon-oxygen bond of the allyl phenyl ether, it will be breaks. Okay, this the bond here, it will be breakdown. This is the bond here. Okay, how this it will be happen? I will explain for you. What we have here, double bond. Yes. This is the double bond. This double bond, it will be open. to make a new bond. And this double bond directly to be converted to here. And this double bond, it will be open to the oxygen. Okay? Give you this intermediate. Give you this intermediate. Oxygen, and we have this new bond, 1, 2, and we have hydrogen. Okay, now this intermediate product is like what? Ketone form and enol form? Ketone form. Yes, it will be converted by tautomerism to the enol form. This here, it will be make double bond. Sorry, we have double bond here. To make double bond, and the aromatic system, it will be gone back, and this, it will be open to the oxygen, and the hydrogen, it will be transferred to the oxygen atom and give you the final product. This, the OH, and you have here 1, 2, 3. Okay? This is the mechanism for this rearrangement. Okay, 2 minutes. So, homework here, resolve homework, show how you can synthesize this, the allyl ether, how you can synthesize that by using this Williamson synthesis for ether. You can prepare this type of compound. This type of compound, the system can be entered to the rearrangement. Okay? To the rearrangement. What are compound A and B in the following reactions here? You have to write it, and you have many. Actually, you have many homework after that. Yes, this whole homework for you. This homework for you. All this homework for you.